let's talk about series and parallel arrangements. This is just an overview. If you want more problems, you can always check out in the course section in chemicalengineeringguide.com. So arrangement is essentially how you put the pumps in order to achieve a certain goal, which might be, I don't know, maybe increase pressure, increase head, increase flow rate. We can do this either in series, which is one after another. So here it goes in the inlet, and the outlet of A is the inlet of B, then goes out. Or you can separate the flow rates and work with each separate flow rate, and then you get back. That's the parallel arrangement. So let's talk a little bit on parallel arrangement. It's ideal when the flow varies. So that means if you're changing, you can always increase or decrease this flow rate because you're going to split it, so the load is relatively lower in general. The pressure is maintained, so that's cool. And the system capacity is increased. So what do we mean with the system capacity is that because we arrange this, we're going to see that the system capacity is greater. What do you mean with system capacity? This means that the quantity or flow rate increases and pressure will remain the same. So instead of increasing the pressure that much as it will be in series, you will be able to process more fluid flow. So you are sacrificing pressure increase to get more fluid flow. So let me show you what's happening in the diagram. Recall this is the system head or pump head, and this is the flow rate. I got this from engineeringtoolbox.com. Awesome page, go and check it out. This is the system curve, and I have one pump right here, and instead of having one pump right here, if I have two pumps in parallel, will happen this. The quantity of one, let's say this is Q1, and then Q2. So actually I'm going to be able to have more quantity using the same head of the pump. Okay, hopefully you get that because we're going to analyze a little bit more on the next ones. So what's going to happen is you have this Q1 and you have this Q2. This is one single pump, and instead of only getting Q right here, we're going to get twice Q. And that makes sense, but what will happen if we choose pump in series? It's ideal when pressure is a parameter important. We want to increase it, so this is the best option. If you want to increase pressure, you need to use series arrangement. So adding a pump will increase the pressure and the flow rate remains the same, so that's obvious. You have one here and you have other one right here. The flow rate is the same, and the pressure is going to change because this pressure will be less than this pressure number 2, and this pressure will be less than the final pressure. So as you can see, you are increasing the pressure way much more than that in the parallel arrangement. So when you arrange in series, you are looking out for a pressure increase. And then what's going to happen is you have your system curve here, and this is the single pump. This will be the normal operation. But when you add another in series, so you have these pumps, what you're going to do is increase the head. So previously we were increasing the flow rate. Now we're increasing the head of the system. So this will be having two pumps right here. And let me show you the comparison right here. Pump series versus pumps in parallel. So pump series, as I told you before, is going to increase the head of the system, which means that you can increase the pressure, and in pump in parallel you're going to increase horizontally, which means increase in volumetric flow rate. So just keep that in mind, guys. And the important here is what application are you doing? Are you interested in increasing pressure, or are you interested in increasing volumetric flow rate? Now once, for example, if you want to vaporize a material, well, you want to go for the pressure one. You want to sorry, if you want to pressurize, not vaporize, doesn't make sense. If you want to increase the pressure, well, go for series 1. If you want to move a huge amount of fluids through a pipe or so, you will probably go through the parallel pump arrangement. This was a free preview. If you want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, then you have the sections. If you're, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.